The State Route 71 Blackbird was an engineering marvel, designed to operate at extreme altitudes and Mach 3.2 speeds. Its defense was simply to accelerate, and its pilots flew high enough to observe the Earth's curvature. The design of the Blackbird was an exercise in conquering extremes, tackling high-speed, volatile fuel, and immense heat. This required fundamental innovations in propulsion, fuel and cooling, and heat-resistant materials. The State Route 71 faced the Mach 3.2 propulsion paradox. Turbojets choke at supersonic speeds, while ramjets only work when already flying fast. The challenge was building an engine that could function as both. The Pratt Whitney J58 was a hybrid engine. At low speeds, it operated like a conventional turbojet. At Mach 3.2, it transitioned into a ramjet, with the core engine providing only 17.6% of the total thrust. A movable inlet spike was crucial for taming the shockwave. Its core function was to slow supersonic air down to subsonic speeds before it entered the engine compressor by creating a series of shockwaves. The bypass system transformed the J58 into a ramjet. Air captured by the inlet was routed through 6 bypass ducts into the afterburner, turning it into the ramjet combustion chamber. Mismanagement of the shockwave could cause a dangerous unstart event. The State Route 71 was literally built to leak. The constant thermal expansion and contraction at Mach 3+ prevented the use of heavy, rigid fuel tanks or plastic bladders. A quote, total wet wing system was used, with fuel contained by the skin itself. Fuel served as both ballast and a coolant. The State Route 71 carried 59% of its wet weight in fuel. A special fuel, JP7, was circulated to cool critical components before being sent to the engines for combustion. The JP7 fuel was so stable, it required a special chemical for ignition. Triethylborane, or TEB, is a pyrophoric chemical injected into the engine to spontaneously ignite the fuel and start the main combustion cycle. The true speed limit of the State Route 71 was the heat barrier. Aerodynamic friction generated immense heat across the entire airframe, reaching temperatures of up to 649 degrees Celsius. The SR-71's black paint was a counterintuitive choice for cooling. At altitude, heat from aerodynamic friction was a far greater factor than solar radiation. The black paint had high emissivity, helping the plane radiate internal heat away effectively. Titanium was the material of choice for performance, making up 93% of the structure. It resists temperatures up to 600 degrees Celsius without losing strength, unlike aluminum. However, it was expensive and difficult to work with. The State Route 71 Blackbird represents a legacy of, quote, impossible engineering and systems integration. Its successor, the State Route 72, targets Mach 6 operation, using autonomous control and advanced materials like 3D printed titanium.